welcome to Researcher Revealed. I'm Dr. Rosalind Austin, host of the podcast that goes beyond just the name on a conference proceeding or journal article or presentation to find out more about why that person is doing the research that they're doing. On today's episode, we have a very exciting guest. His name is Lars, and he is an AI machine learning engineer, I think is how he described himself. And we dive down into the research that he's done around creating a generative AI platform in order to be a companion to clinicians to make their administrative workload lighter. Give it a listen and let me know what you think. Hi, and welcome to the next episode on Researcher Revealed. On today's episode, I'm very excited to have Lars all the way from the Big Apple, New York. Lars, can you introduce yourself to everybody and tell us who you are and what you're researching and your role within research?
Yeah, of course. And thank you so much for inviting me. Just a quick correction. I'm actually sitting in Brooklyn. I'm originally from Copenhagen, and that is as close to New York that I could get because I'm still a small town kid. I realized that from being in New York for some years. That's also why you can hear my accent, that it's very Scandinavian still. My name is Lars Maaløe. My background, I've done a lot of machine learning research. My PhD thesis was on deep generative models before deep generative models was a thing, and before it was called generative AI around the field. I was focusing on semi-supervised learning, this crossover between supervised and unsupervised learning. With these deep generative models, I was focused on a Bayesian approach, so very, very methodology and model specific as a background, and did a lot of research within that. I've been publishing at Neural Information Processing Systems, the International Conference of Machine Learning, all of the big machine learning venues. I still am, and I am still a vivid researcher and love that field. And then I started Corti together with my co-founder Andreas Cleve back in 2016, and we started as a research lab focusing on how we could use machine learning to augment or perform augmentation of medical professionals. We focused on the emergency medical services space, and where we are today is that we have created this big API infrastructure providing AI for healthcare in a general sense for everything from family medicine to the very, very complicated inpatient cases. And what our machine learning is doing, it can listen in on conversations, it can generate text, so back to the generative AI, it can classify, back to clinical coding. We have agents and more agents coming out. They can do a lot of tasks within healthcare and support various software vendors and big healthcare providers with making their workflows easier.
Wow, I cannot wait to get into that. Now, I'm going to slow things down just a little bit because I think you are the second person on my podcast who isn't classed as a clinician. So technically, your background, would you class yourself as a software engineer, as a computer programmer? What would you sort of class yourself as?
Yeah, it's a good question. I would classify myself as a machine learning engineer. And what is that? From a trade perspective, you need to know statistics, software engineering, and you need to know data analysis and stuff like that. So there are a lot of these traits that you need to be very, very comfortable within, and you need to be good at math. Without it, you have a problem.
We'll dive into that a little bit more because I did take a sneak peek. I looked at some of your papers and it brought back memories of advanced calculus, and I actually did a course. I'm trying to remember what the math course was, but it was around computing math, linear algebra. And I was starting to have panic attacks looking at those formulas again. But we'll shelf that for a minute because otherwise I'll get distracted and I'll forget to ask you the Researcher Revealed Rapid 11. So are you ready?
Yes.
Are you a Windows or Mac user?
I'm a Mac user.
Okay. Tea or coffee?
Coffee.
Okay. When you're writing, coding, doing math, whatever you're doing, Is it silence in the background, or do you have music playing?
That's a good question. It's a mix. Music.
Oh,
I like music, and it varies from my temper based on what I'm doing. So
oh, that's brilliant. So you have like frustrated playlist, you have happy playlist, you have coding playlist. Cool. I like it. I like it. Very excellent. What time of day, generically, would you say that you are most productive?
in the mornings, early mornings. So
Okay.
I also have small kids, so yeah, I need to live by that. So I wake up extremely early. Also now they're sleeping a little bit longer now, and I'm
Mhm.
still waking up early, so that helps me.
Nice. Very cool. Where do you tend to work? At home or in an office?
In an office.
Okay, cool. When it comes to your publications, do you have a favorite referencing management system? So
No,
things like EndNote, Mendeley, Zotero, that sort of stuff.
no. I've tried them all, and I am using them all, and I don't have a favorite.
Okay, which one are you forcing yourself to use then?
I think right now I'm forcing myself to use my own system.
Ooh, cool.
I'm a vivid user of Sublime. I'm old school in that sense, so I have a lot of note takings and so on. And then I've integrated a generative AI agent into that, so that helps me out on summarizing and stuff like that. But I will not encourage anyone to do that. I think actually my system is maybe the stupid system, but now I'm bought in and yeah, a little bit too proud to change it.
I love it. I love it. It's brilliant. I like it. Customized system. Whew, excellent. What about when it comes to your in your publications, in presentations, when it comes to data visualization, whether that's your complicated formulas, whether that's graph, what's your favorite tool of choice?
So I'm a big Python user. I will keep on being a big Python user. So Matplotlib is yeah. I know that.
MATLAB.
No, Matplotlib, the
Oh,
library
okay.
inside
Sorry.
Python. Yeah, I've also used MATLAB back in the days, but no, I'm not using that anymore. But so that would be my favorite visualization tool for pretty much everything. And yeah.
Nice. I'm jealous of that skill set. Um, right. When you're sitting at the desk, do you have a favorite snack?
Um, I have a tendency of forgetting to eat, so that's my big problem. I drink a lot of coffee, and then I guess my favorite snack is when I remind myself that I need to read, especially when I'm in focus mode. Then I'm finding out
Yeah.
that I was unproductive for the last 2 hours, and I probably should actually get some food. So yeah, it's more of
Fair
what is
enough.
there.
You're
Yeah.
you're not alone in that. There's quite a lot of people who are into research who do similar.
Yes.
When you're planning or organize, whether that's for like another agent within Corti, whether that's a publication or a new project, are you a pen and paper planner or are you a digital planner?
Digital mostly, and how I love planning also, especially our research roadmap, is that we always write the abstract, and we try to write it full-heartedly, and then we find out whether that's the abstract that we should go for, or whether we learn something new on the way.
Oh, that's interesting. I've not heard that before. I really like that. That's really cool. Right, two more questions and we're done. What book are you currently reading?
So right now I'm reading so quite frankly I'm reading several books at the same time,
Okay.
and sometimes I'm getting blocked in one of the places. I'm reading the new Sam Altman book, which is a must read about OpenAI and giving some more insights into that.
Okay.
Then I am reading the new Ronald Reagan book. I like these
Oh,
political biography books, and I think that learning about Ronald Reagan and getting a little bit more insights a lot of years afterwards is amazing as well. And then I'm reading the Hail Mary book. So that's
okay.
more of a fiction book, and it's my humor is bad, but I think it's really really funny. So
Your humor is not going to be half as bad as a healthcare professional. So, what I'll probably ask you to do is maybe after we finish recording today, I'd like to include the full titles and the authors of the
of
books. And
course,
since you
of
had so
course.
many, if you can just drop those in an email to me, and then for everybody who's listening or watching, check out the episode description to get those books so that you can follow in Lars's whichever book tickles your fancy that Lars is reading, because he gave you 3 choices: coding, politics, or fun fiction.
Yes, sci-fi.
Brilliant. Excellent. Last question before we dive into getting to know a little bit more and revealing about why you do research is, who is a researcher who you admire?
Oh, a lot of people. I think that one of the researchers that I've probably admired for the longest is Geoffrey Hinton, one of the godfathers of AI, which is commonly known as. I think that all the way from his work on backpropagation, all the way to especially his 2006 breakthrough with Ruslan Sadakutdinov on dimensionality reduction with these deep autoencoders. I think that was the breakthrough and the real initiation of deep learning. So I would be very, very untrue to my space if I didn't choose him as a researcher. I'm very, very impressed by that.
Okay, cool. Thank you for that. Right. So now getting into why research for you. Now, as an AI engineer, computing person, why did you choose to become involved in not just the research around like AI, generative learning, language models, all of those things that you listed, but why with the additional filter of the healthcare space?
Yeah, I think so. First and foremost, generative AI was like it seemed like for the common breakthrough, it seems like such a big epiphany, but it has been on the way for a long time, right?
Yeah.
And I think that one of the key things from getting into machine learning and getting into these deep generative models was that back to Richard Feynman saying anything that I cannot create, I do not understand. I think that that is a good angle for these deep generative models, right? Because the other models that was before that was basically what you call discriminative models. So you discriminate between 2 data modalities, and that doesn't make you understand anything. It just makes you like back to linear regression from high school and stuff like that. It makes you linearly discriminate between 2 data sources. And I found it very, very interesting whether we could build some models that could really, really understand. Then we can actually ask ourselves whether nowadays machine learning really do understand, back to the Apple paper on the illusion of thinking or reasoning and so on, and then the counter papers on the illusion of thinking and the illusion of the illusion of the illusion of thinking. That's a topic for the research space right now to actually find out whether it's true reasoning. But I think that creating these generative models has always been a really, really interesting point from my perspective. And then back to healthcare, to answer your specific healthcare focused questions, I think that it's very, very few areas within the world where you can, from a computer scientist perspective, really create something that is meaningful. And I think healthcare is the underlying, as far as I'm seeing. So I'm raised in a family that are either engineers or doctors and nurses. So that's basically the 2 areas that I'm raised with. So basically, the apple doesn't fall far from the tree, I think you say in English here. And yes, I am on the tree still, it seems. And healthcare I find as a crucial infrastructure, and a crucial infrastructure that is having all of these problems that could actually be helped out with some more technology. And we have seen the transition of technology in the last many years inside this expert system of healthcare that has done amazing things, but it doesn't feel very, very overwhelming in terms of the things that it has done, right? We have introduced electronic health record systems. That feels like that is amazing, but it also feels like not that fantastic, right? It's basically a documenting and archiving system at the very end of the day in workflows. And it feels like we need to be able to do more within healthcare, within everything from the workflows to the discovery of new medicines and all of that. And I think that that must be one of the most interesting things from an engineering perspective to work on. And yes, I am an engineer by heart, so everything that I can work on that has an impact on something where I can go home and feel I built a product, or I was a small part of building a product that had an impact, that's fun.
That's really cool. That's really cool. Thank you for sharing that with me. So we understand why the desire to make an impact, that possibly likely familial influence of having people in healthcare in your family as well as engineers coming together in you. But what about now like, yes, you said about Richard Feynman, like wanting to be able to, in order to understand things, you have to be able to create it yourself. But how did you end up going from doing your undergraduate degree to completing a PhD to then going into this space now where you are using research to fuel, to develop, to garner more transparency around this Corti platform? We'll explain that in a bit, but how did that journey go?
Yeah, so I think mostly when I get really excited about something, then I start working, and I don't look up for a long time. Back to the problem about not eating wild. So I think that my first big initiation. So I was first and foremost within the computer science,
Hmm.
and was quite knowledgeable about building software and stuff like that. I started a small consultancy agency on the side of studying and whatnot. And then when I got my first hands on learning a little bit more about this deep learning wave that was at the very initial
Yeah.
kind of a wave. That you see right now, I got really excited because it was so obvious to see that if you could make these approximative models that was trying to approximate something, then you could actually program less
Yeah.
and let these models actually think it through. So the first thing that I was focusing on there was within everything textual, because text, there was a lot of it. I focused on topic models. It was called at that time. Now it has many other names, but it's still, a lot of it is still topic modeling.
Hmm.
I got really excited about David Bly's work on Bayesian topic models. It was called LDA models. And I think that I got really excited about the combination of deep learning and the Bayesian approach, which I think is actually still an unexplored or
Yeah.
underexplored
Yeah.
the theme here. Where just quickly on these, like what we use in these autoregressive models right now, they're still very simple in their next step predictions, even though they can do amazing things. I think that talks a little bit about what we as humans are actually spending a lot of our time on, whether that's actually that intelligent. But let's save that for later. Where these Bayesian models, they try to learn a probability distribution over the domain that they're functioning within, and that I find extremely exciting. So that was what spawned my real interest within this, and from there on, I basically continue working and getting better and better until, and the only way that I foresee that you can keep on being better, or that's at least the only thing that I know, is being on top of research. So every time
Okay.
something new comes out, I need to understand it. So I'm a vivid archive user and almost an archive alcoholic here, if there's anything called that way. Machine learning research is one of the frontier areas where archive got really adopted fast. So every new paper is coming out on archive also before it's actually getting published at the venues.
So,
Yeah,
so I'm going to press pause there for a minute, because for
yes.
people outside of computing science, I'm including myself in that. What do you mean by archive? Is that like similar to like a preprint repository within healthcare system, or is it something different?
Yeah, so it is. It is.
Okay.
So it's basically a preprint that you can where you can submit your paper. So machine learning research, the biggest venues within machine learning research, you can go in and look at the indices within Google, are these big conferences, and
Yeah.
they have conference papers. And these conference papers are normally 8 pages long, etc., with a large appendix with all the proofs and theorems and all of that.
Yeah.
Archive, you're allowed to, within the machine learning community, to preprint and publish that preprint on archive, and that's giving
Okay.
such a motion to the machine learning
Yeah.
environment. So thereby you don't have to wait for the 8 months or whatever until your paper gets out, but it gets out
Yeah.
immediately. So a
Yeah.
paper can already get really popular before it's actually presented at that conference, and that is giving speed. It also
Okay.
gives the problem or the risk of getting a lot of noise out there. But I think, in all honesty, I think that noise is combated by the conferences being really good in their review processes.
Okay. So within, just to kind of um again start to frame things, because you're in you're starting to bridge this world between this upcoming digital revolution all around the world in healthcare, which is this very deep, in-depth, different world within computing science, machine learning, AI, all of that sort of stuff, and healthcare. And I mean, you're saying 8 months track in healthcare it's like way longer than that. And so just really interesting because one of the things that I see happening, and it's a really big discussion, is that within healthcare, research becomes so slow that by the time you do the fully peer-reviewed study and get the funding for it and yada yada on that piece of tech or that AI generative solution or algorithm or whatever. I mean, that ship has sailed and three more have come behind it that are totally different. So do you think that like the within the computing science that process of having those readily available and maybe yes, some noise in there as well, but that helps with the speed of things for making sure that you're constantly refining and improving these models so that they do the job that you're aiming towards.
Yeah, I think it serves two purposes, right? Because the danger here is that the listener will think, oh no, he's against the reviewing process. No, far from it. So I think that it serves two purposes. That the review that there is a there is the opportunity for a pre-review process. From the preprint community, and that preprint
Yeah.
community will start actually validating your results. So a lot of what you like, if you want a paper that is really, really highly cited and all of that, then you
Yeah.
also need to publish your benchmarks, your data sets, etc., for other ones to replicate that. So maybe you can even get people to replicate it before it goes into the review bundle with those five
Oh,
reviewers and all of that, right? Those five reviewers,
wow.
etc., would then start reviewing in the same old fashion, and that's an additional like
Yeah.
stipulation that this paper is
Yeah.
a good paper. So I think that yes, it serves to argue that you can start really really making good papers. We
Okay.
have for many of our papers sent the first version out to archive, gotten some feedback on the way, gotten the second version in there or third version in there with small like adjustments or more appendix and all of that because people were wanting to have that appendix or publishing some of the code behind it as the people could replicate it in
Yeah.
the midst of having that review process. So I think that it serves nice angles, all of it.
Yeah.
And yeah, it's a good
No,
yeah, go.
Thank you for sharing that because I think like highlighting some of that understanding around that different context within the computing world is really, really important because exactly like you said, I think the fear is within healthcare people who haven't had conversations with people like yourself who are looking at how science happens in the computer. And I mean, I went to a computing science conference, more of a health informatics conference for the first time. And I was just blown away last year. And I was blown away by how different the format is. Because in health conferences, you submit a 350 word abstract and that's it. And you're judged on just that little abstract. And some conferences now allow you maybe like one figure or two figures to go with it, but that's it. Where in the computing science, you actually have to submit a lot more information that then goes through a review process in order to then be accepted or rejected or refined or whatnot. And so it was a real like eye-opening experience for me to see how differently that research is produced and then implications for that if you wanted to collaborate with a healthcare researcher, whether it's a doctor or nurse or whoever, and then where do you produce your work? Do you produce it in two places? And how do you then balance those two very different tracks and very different pathways in order to get the information out to all of the communities simultaneously? So
Yeah.
it's really
Yeah.
interesting.
Yeah, I think and where you should probably see these machine learning conferences and their proceedings, you should probably see them in relation to a journal publication because that's the relation that it should be perceived as.
Yeah.
And yeah, I agree. And I think that the reason why this is possible within computer science is because you're able to reproduce so quickly, and you're able to actually like get a grasp of the research results so quickly. So this is not a big lab testing environment, right? So that kind of
Or even worse, human test environment.
yes, yes, yes. I did mention that for a reason here. So yes, I agree. And I think that where it really becomes interesting, at least from where we are seeing a lot of these, because we're coming from the computer science perspective, also from A/B testing. We A/B test our product a lot, right?
Yeah.
And where the big clash is coming into the school of RCTs and how to structure those RCTs and all of that. And I think that we could learn a lot from both sides, at least in terms of actually structuring those tests as good as possible.
But I agree. And I think that's why having conversations with people like you, I find really informative as a nurse researcher, because it helps me better understand that world. But then it's also for me about really starting to think about, okay, how can we make these two worlds connect so that we can have, like, yes, we have the evidence behind your algorithms and what it does and how it functions, but we also then have the same technology or revisions of that technology, that programming, that model, that we can then apply to human data and humans themselves and test it in a way that clinicians then start to be able to have faith and trust and desire around the implementation of it. Because like I said at the beginning of the episode, I did do a little bit of trawling on the internet for you, and with the program, which I will get you to describe in a minute, that you're now co-founder of, you talk about in that program the background information of it. You talk about wanting to implement it, and you talk about how in general within not just AI, but in digital health tech solutions, the amount of waste and the amount of not linking up and the amount of not fit for purpose is massive. And so I think these conversations and collaborations, we need more of them so that we can both understand each other's worlds to make things better.
Agreed, agreed. And I think that one of the things, at least, that we see more and more of, like where it becomes really strong, is when you can incrementally improve research results, right? When you get into that field, then that's where the magic is happening. And yeah, so let's do.
So moving on, because time is flying by. Corti. What is it? Why did you create it?
Yeah, I think so. First and foremost, within healthcare, as far as we see, and I say this in the most humble way, because I feel like I'm still learning a lot about healthcare for every day that goes by, and I feel like I'm getting schooled by clinicians and nurses and like clinicians in general across healthcare sector every day, and I'm learning new insights into the workflows and all of that. But as far as we saw when we started this company, we saw that the best thing that could happen to healthcare is that if we had 10 times as many doctors and nurses in healthcare. And at any patient encounter, there would be 5 doctors and 5 nurses sitting there, and they would listen to what the patient had to say. They would have infinite amount of time, and they could have a majority voting session afterwards and have a second opinions episode and all of that. So then healthcare would be solved.
Yeah, I'm not laughing at you, but it's so interesting listening to somebody outside of healthcare describe actually what we need, because it when you put it as you've just done, it does sound slightly like, how on earth are we ever going to do that?
Yes.
Anyway, continue.
And then I guess that's the segue of the second best option, right? And that's using computerized systems to help us a little bit on the way there. And I think that that's the positioning within healthcare that we should really be mindful about, because machine learning can be really, really good, and it can be really, really powerful if it's utilized correctly. So the first mission from Corti was quite obviously, could we create a machine learning system that could have an augmentative power on a healthcare professional? So that means that could it help them on driving some decision in the process? And that's what we started our research around Corti, like asking ourselves this very naive assumption: could we do that? And we went into the whole spiel of RCTs and all of that, and we did that for a very sub-segmented focus, and we came out with a model that could actually have this ability, that could have a understand a live conversation between two human beings inside healthcare, and it could give some advice that would actually go for the better of the patient. That was the first initiation of Corti.
Okay.
What we have built today is a fully fledged API
So
infrastructure.
what does API stand for?
So API is basically a fancy word for giving a lot of plugs into an AI system. So look at this as your cords in your walls, or your plugs in your walls, where you can put your cords in, and then you get some new functionality in. And an API layer here is allowing for a lot of backend services to be promoted to anyone that wants to integrate to that. So, for instance, this conversation is a video conversation where we have an application. That application is using some server somewhere that is crunching our data, the video signal, the voice, and all of that, and that is done through an API. So when you want to build an application within healthcare, then you need to be using some API functionality for that application to get smart, to be useful for whatever you want to build that application for. So we have built that backend, so to speak, of technology that hosts a lot of machine learning. And all of that machine learning, they can understand what is being said inside a dialogue, so speech recognition and so on. It can generate text, it can analyze text, and then it can analyze the voice thereby through the text and all of that. And it can analyze also clinical information according to that text. It can correlate those sources and so forth. And then on top of that comes all of these agents that can do a lot of actions within that domain. So if you want, for instance, ambient scribes are a big thing within healthcare right now. So an ambient scribe software is basically a software that where you open a microphone when you have a conversation with a patient. You press play or whatever ambient scribe tool you have. Then the microphone is open, it listens in. What happens when you have that conversation with the patient is that the audio is sent to a server. That's the backend to an API. And that server is then processing that audio. First and foremost, it's transcribing it into text. And the better it transcribes it into text, the better the end result. Of course, if it doesn't understand all of the medication terms, if it doesn't understand all of the clinical language and all of that, then you have a problem, then you get a bad result. Then after that, when the conversation is done with a lot of these ambient scribes, you click end on your iPhone or whatever device you have, and then the processing of the live of the clinical note will happen on that backend server, and that clinical note will be sent back to the device for the clinician to then revise and review. So all of that, like on the backend, we can do on the backend, and we provide those plugs for people to plug into. So whatever application that is out there can use those plugs, and then they can get that functionality.
Okay, so you're saying like your platform, Corti, that isn't necessarily, as much as it's an independent tool, it can be plugged into a given healthcare system that's already existing. So in New York and Brooklyn there, if a given hospital is using system X versus Toronto, Canada using system Y, you can add it on. You can add it like as a plugin. So like in R, you can have all those different plugins that then do different things to your data. Yes? Am I understanding it?
Exactly. And depending on what software you're using, like a clinician is using an EHR, electronic health record, or EMR, like depending on where you are. And they're using their invoicing system that can be through the EHR, EMR, or code classification system, and they're using they're using maybe an ambient scribe. They're using a dictation solution and all of that to fuel all of those solutions with AI capabilities. That's where we come in, and we are there is a high probability that we're fueling more and more right these days, because we're doing well. In terms of our API progression and also adoption here, and where the big competitor within us are the big closed sourced LLM providers and all of that. So the OpenAI, the Anthropics, and all of that. So that there's a big chance that if not us fueling that backend, then it's one of them fueling that backend.
Okay. So with your program, the ultimate output in it, like that basic version, so not your fancy added ones that you've done, but just focusing on the basic one, the whole purpose of that was to, like, one of the banes of every clinician's life is that documentation of that interaction between patient and clinician. So your foundational Corti program was about converting that audio conversation into what depending again where in the world you are, that clinical documentation. So whether it's a letter in the UK or electronic healthcare case notes, things like that. And then now your additional extra agents, are they now doing things like monitoring medication prescriptions, blood results, things like that, or is that not yet there?
No, so the fantastic thing is now when you plug in to all of the plug your code into to all of the plugs here, then you can get the full experience. So you basically get the full experience of being able to have a patient, and you ask into give me the top clinical guidelines from a specific guideline provider and give me the summarization of those guidelines for this specific patient, and give me the explanation to why those specific summarizations are the ones that you have chosen for that specific patient. Give me all of the ICD-10 codes for this patient as well. Give me the explanations why you chose these or why these ICD-10 codes and not something else. Give me the explanation where in the transcript, like the conversation, that this happened. Give me the medications that are already prescribed for this patient, and find out whether these medications are aligning with the medications that I mentioned in the conversation. Now you can start having very deep dialogues into the extent of the patient history, to the extent of the current conversation, so on, so on. And this people can now build agents on top of our infrastructure.
Wow, that sounds incredible. So I'm going to preface my next questions with, I am a nurse by background who is doing my best to learn around digital health technologies. But in comparison to you, I don't know anything. So if my questions are dumb, then please forgive me out there, not just you, but the rest of the world. So with your platform and this generative AI programming engineering package that you've built, to what degree have you used synthetic data sets to train it, and how much have you used real data sets to train it?
Yeah, it's a really good question. So what we are our base models are getting so good nowadays that training these base models on certain like outlier, like healthcare is such a power distribution, right? So you have like a low prevalence at the tail, but that tail is really long.
Yes.
So you get a bad representation inside your real population data set if you for the tail of the distribution, if you just rely on the actual real life data. So if you look at it from a data perspective, I'm sorry, I'm so biased into machine learning here, but then you need synthetic data to actually up the volumes and cases for these tail distributions. And tail distributions, like if you look at the whole tail, it accounts for a lot of volume. It's just so diverse, and that's also why people are such experts within healthcare, right? Because you have seen one of those cases before. Back to finding the zebra within healthcare, right? Then you know that you should be careful next time, right? The meningitis incident,
The rare cases. So again, by tail, again, just helping with analogies for my clinical colleagues who will likely be listening to this to help them kind of understand. You're talking about that probability curve. So the 5% on either side of your average patient that don't fit those curves, those frameworks, those suggestions, stuff like that, in order to train your model on being able to better understand and advise on those cases, you're arguing that actually it's better not to use to supplement real data with synthetic data.
Yes. Yeah, exactly. Because like machine learning is the training within machine learning is still quite dumb. I'm happily getting quoted on that, right? Because you need to show it a
Say
lot
that
of
again.
examples.
Say it again. So machine learning education is still quite dumb.
No. So the training of machine learning models is still quite dumb. So these
Okay.
models need a lot of examples to really learn it.
Okay.
And they need the diversity in these examples. So when I tell my son that our stove back home gets hot.
Yeah.
My 4-year-old son is quite easily able to generalize that to another stove somewhere else in another house and thinking that stove is probably also hot. My father told me maybe he has even experienced it and that he definitely knows. Machine learning models, they need some more examples. They need 5 stoves, and for us to tell them all of these 5 stoves are hot. They're getting better at what you call generalization, but they're not there in terms of what a human could learn from. So you could, like, I think that a good like visual representation of it is what's called the ladder of causation, where you say machine learning models are really good at seeing data and finding correlations in that data. When they start to interact with the environment, similar to us learning the laws of physics by first throwing the glass of milk down on the floor and see how it lands, right? And then the 5 next time we do it is just for the fun of it because we learned the laws of physics in the first one. Then the third ladder of causation is the ability to imagine something. So we are thereby able to generalize something, right? We can sit here and learn from one example, and then we can start imagining, okay, that must also be true in these other examples. Machine learning is not that good at that. So we need to show it a lot of examples until it has then learned it. And therefore, we need a higher prevalence of those lower distribution cases to make sure that there's synthetic data generation that are small anomalies in terms of the data sets from the real world are really, really useful.
Okay, so that makes sense to me. Then because one of my worries, and I've had a conversation, not at this podcast, but somebody who I know who's a professor in AI, he gave a talk at the University of Stavanger around the potential innate bias within AI because especially in health, the data that we're feeding AI is incredibly biased. So like if you go to, I know cardiology best, but if you go and you did a quick rapid review of every cardiology paper, regardless of condition or treatment or medication, you're going to find very few females. You're going to find very few ethnic minorities. You're going to find very few people with cognitive issues, things like that. So does synthetic data then have the ability to supplement that real data to make it more inclusive and less orientated towards the male, the middle-aged, and the Caucasian?
Spot on. And the fun thing here is that we can start to simulate it. So we can start asking these assumptions. Could there be a bias here? Could we validate that with a validation set, you would call it? And then you can start interrogating the model. And the nice thing about the machine learning model that it's more or less deterministic by design. So you know that when it has learned a mistake or embedded a mistake in terms of bias or in general some bias, let's not call it a mistake by design, but some bias here, then you can do something about it. And that's the beauty of this, right? So you can start to interrogate this, and there's bias all over healthcare, right? We've seen that for years, where when a cardiologist needs to take that example, when they need to diagnose someone, there's a high probability that it's within cardiology that they diagnose that someone, right? So I think that machine learning as an underlying framework here in companionship with the healthcare professional is enabling us to really start interrogating towards these biases and thereby getting rid of them slowly. And I think that that is where to pull you a little bit into my core research. That is basically this Bayesian approach of going towards machine learning is trying to find out the known unknowns and the unknown unknowns. Because if you know the known knowns, that's within your data set and all that, your population. Back to what you said before here, that is where you have your data set population. It's middle-aged white men. We're good at categorizing those middle-aged white men. We could probably get a Nature paper out that says we're good at that. And then we find out that the known unknowns, our data set doesn't have female representation, right? That's a known unknown. Then we start asking the assumptions on that female representation, and then we can say, our model is not doing good, or it is doing good, and that's another finding, right? Then the unknown unknowns is the question that we don't know actually to ask the model. Maybe there is a racial bias that we didn't know from our clinical perspective because we didn't know that there was a a difference. I think that the radiology is a really good example of that, where there has been findings in terms of a racial bias in that, right? And that's an unknown unknown that is uncovered, right? Using machine learning to also try to investigate some of these unknown unknowns. They would do that through pattern matching, and then say, this looks like an anomaly. The machine learning would have no clue why it is an anomaly, but flagging that to a clinician that would then say, wow, this seems weird. We need to investigate further and make this a known unknown and then a known known.
Okay. Okay, I see. Yeah, no. It makes really, I find this really fascinating because I think, again, it's like everything that's new and shiny. You have the evangelists for the new and shiny, and then you have the anti-evangelists. I don't know what the right word is, but like the haters, we'll use the haters, who make a lot of knee-jerk assumptions about something that they may not have fully understood. So I think, the way you just described that, like, to me, is a baby in this world, and just starting to understand this world really helps me better understand like what you're trying to achieve and the purpose for using those different data sets, and the sort of self slash partnered evaluation that you're asking these models to do on themselves, that actually potentially has the possibility of exposing stuff that we as humans haven't even thought about, which then the impact and potential good that might do, that's incredible to start thinking about that.
Exactly. And it should be seen as a companion, right?
Well,
These agents are, yeah.
I absolutely love how you keep, like, even at the very beginning when you talked about your sort of like goal in your research, you use that term augmented, and I was going to ask you about it, but now you've switched to using the word companion, and I really like that because I think from everything that I've read and what I'm hearing and you discussing your research work a lot more, is you see this generative AI tool as that. It's a tool. It's not a replacement, but it's how can we actually make that clinician's life better, which then means they can help the patients better. And then the implications on that for the generic workload within our healthcare services, we don't even know, because we've barely started scratching the surface on how to use these, because it's like we talked about before, how the programs that are being implemented in a given healthcare system in the world, how much are they, as your model is, a plug-in for an or is plug-inable for an existing electronic healthcare system and dictaphone system that clinician might be using, versus a system that's completely independent, that doesn't merge, that doesn't integrate, and then what does that mean for that clinician's willingness to adopt and implement it?
Yeah, I think you're spot on, and I think that if we could get rid of this bias, so to speak, to use that term here on it's the either or, right? There was this fun research finding where you found out
Okay.
that a mediocre machine learning chess player and a mediocre chess player could beat everyone in the field, right? And I think that's just I think I can try to dig it out afterwards here. It's a little bit old.
Yeah. Give me the link for it, because that would be really
Yeah.
fun to put on the episode
Yeah.
description.
I think that back to the expert, like maybe we should ask ourselves why the expert chess player could not utilize the mediocre chess player as the machine learning, or the expert machine learning expert, right? I think that we should all ask ourselves. I'm not going to go further into that, but I think that it's an
Yeah.
interesting learning in terms of whether we could get the expert and the experts to learn from each other. And just to give you a very, very easy to follow, I believe, use
Yeah.
case for this. Our agents you can now use to basically build a live conversational agent. So you can have a conversation with the machine learning system. And
Okay.
where a lot of people are getting into that, then they're saying, no, a machine learning system should not act as a doctor. And I very much agree on that. I would never make it act as a doctor. But could it act like a data aggregator? So can it ask a lot of questions for the patient and say, okay, just give me the answer to all of these questions, and then flag all of those answers to the questions, and perhaps summarize that for the doctor, such that when this doctor has the 7 minutes with the patient, that doctor has a little bit more information to go from. on exercise behavior, et cetera, et cetera, et cetera, right? Where that doctor maybe would not have asked that question because they simply don't have the time because they're so on, so on. And maybe there would be a finding in 1% of the times here. And we all know from being patients in one way or the other, or having kids that are so on, that you have a lot of time to describe your own problems when you are in the system, right? But the system doesn't have that much time to listen, which is understandable.
Yeah. That's really fascinating. So I think my next question then is, with the research that you've been doing around Corti, its various agents and its integration, have your team started evaluating that system in its implementation, its levels of accuracy with active clinicians who are now using it, or is it still not being utilized in real healthcare situations yet?
It's definitely being utilized a lot, and we are evaluating constantly. And we are also trying to publish as much as possible on the evaluation. What is interesting when you get into, I think that one of the biggest topics in machine learning is evaluation and validation. And it's so difficult. So if you take machine learning out of the picture and just ask yourself on how many effective and positive evaluation metrics have actually been implemented in the normal workflows in your hospital, then I think that you get a somewhat of a sour picture of the McKinseys of the world getting in there and trying to say we've gotten this much more effective, and the employees feeling, oh, I don't know about that, right? So just the validation and the effectiveness, it's difficult metrics to do. What we do a lot is we look at the models themselves, how effective they are on the accuracy, and then we try to segment between the implementation process and the models themselves, because then we can start saying, was it the model that needs to be more accurate? Because that's something that we have full control over at any time, and that we need to keep on monitoring. Or is the implementation process always as good as it should be? There are the first signs of these ambient scribe players that really has a positive effect on the time spent on documentation. That's really, really good, right? That has taken some time to actually get to those effectiveness scores in healthcare. Then the next question is the documentation that spawns from these ambient scribe implementations, is that more accurate? That's something that we work very much on. And I can assure you there are a lot of opinions on what accurate documentation looks like, how concise it should be, and all of that, which there should be. So.
But that's what I was going to say. And that's why I wanted to ask the question around evaluation, because I've been starting to dive down into this, because not just in digital health technologies, but even in like pharmaceutical agents, for the longest time, traditionally, evaluation is, are you alive or are you in hospital? Because those were the main metrics, because they were associated with cost. But I think with the increase of digital health technologies and tools, we need to go beyond that. And even in pharmaceutical, they are now starting to go beyond, are you alive or in hospital, in order to understand the impact of those interactions, those conversations. And, for me within digital, it's that, yes, accuracy, but to what degree, and what do you mean by accuracy? And there's so many questions when it comes to the evaluation of these two, like how is it affecting, pathways, clinical workloads, hours, times? Because if the generative AI is producing, like you said, you have an agent that allows the patient to have a 4-hour conversation with an AI bot that asks lots of important questions, but then that generates a 20-page summary for the doctor to read in order to guide that 7-minute. Now, who's got time for that? So it's about how you make all of this very rich data gathering and identify which components are key. But I don't think, and from the reading I've done within the computing science world, we don't have a good idea yet on how to evaluate the mechanics, the affordances of these tools. Is that right?
Yeah, I think that's where we have a lot of nice tools from statistics and machine learning that can help in these processes.
Okay.
And we should be, I'm always like, there's nothing as conclusive as whether you're dead or alive after 30 days and so forth, right? Those measures, I have to say. So it also feels a little bit too late sometimes if that's your classification of value-based healthcare, right? So I think we all agree on that. I think that we have a lot of opportunities to build causal analysis of what is happening and simulate that. Since now we have a model, back to the Richard Feynman saying, what I cannot create, I do not understand. If we can actually create what is happening out there synthetically as well, then we can start asking some hypothesis on our operations. And we can start asking the machine learning some hypothesis of that. What if the documentation looked like this? What would that have an effect on, for instance, like, to give you a real example here to be a little bit more tangible. So a healthcare provider could ask themselves, after implementing ambient scribe X, did our documentation get much longer? And thereby, do we actually end up having a much more tedious workflow? Because every time someone needed to read the documentation, they needed to read an essay they also generated, right? Then they could ask themselves, was there added more material in that documentation than what was there before, and was any of this material clinically important, right? They can then use the downstream of coding. Did we code more? Were those codes more correct, and so forth? So that causation inside the value chain before the patient is leaving the hospital, I feel or I believe very much in those analysis, and they're very indicative of whether a solution is as accurate as it should be, and that will then give feedback to whether that ambient scribe solution should get more accurate, more concise, and so on, right?
I like it. I like the sound of that, because I think it's one of those things that it is a new frontier, and it's not just in creating the tool, but it's in evaluating the tool. Have you had like any level of mixed method analysis on like clinician feedback or patient feedback from using the systems? Like, are they enjoying it? Are they finding it useful? Or, do you have issues with digital competency, like those sorts of things?
Yeah, so first of all, I would never say that we had an issue with the digital competency, because I think that the engineer in me is saying then we did something wrong with the product, to be quite frank. I think
yes. Whoa, slow down, because I want to break that down a little bit, because I think that's a really interesting thing that you've just said there, that I think a lot of people within healthcare are really worried about, because like when these tools get developed more for patient-facing interventions that I've got experience with, there's a lot of work with the developers that goes into, or the researchers that goes into, making that program accessible for a patient. But there hasn't been as much work around making it accessible or competent for like assessing digital competency within some clinicians. And I mean, I'm not going to name names or anything, but I've had clinicians who like struggle to log into a platform, and I have to sit with them and hold their hand and help them do that. So I think, yes, there are design elements to digital competency, but there's also issues around actual digital competency, trust, and all of those other issues as well. But you think, as an engineer, that that's a non-issue, except for if you're a rubbish engineer, which I find fascinating.
At least I would love to perceive it as that, because I think that it's so easy to say the doctors that have a difficulty on remembering the 10 passwords and not logging into the platform, they're still able to log into their iPhone and use that in the everyday basis, right? So I think that it's so easy to be harsh on this competency, and I don't think it's fair.
Okay. I like it. I like it.
In terms of on the topic of these solutions that we're bringing into healthcare, on the ambient scribing and so on and so on, I think that where I really see to give I'm trying to get two examples instead, because I have so many different examples of use
really
cases.
Helpful, Lars.
So let's take ambient scribes, because now we're talking about ambient scribes, right? A lot of doctors have actually been used to using dictation solutions for a long time, right? They were sitting there with their microphone, and the ones that have tried it for a long time, and you say old school now, right? But let's just revisit that. That's a 20-year-old technology, and they're super efficient. When you see a doctor that has been working with that for a long period, then you see them like they're getting their note, especially how they liked it, down in 20 seconds, right?
Yeah.
Then we come in with these ambient scribe solutions. That is, a lot of them are implemented where you press a button, then you record the conversation. First and foremost, it's a little bit awkward because you need to say to the patient that, by the way, I'm recording this, and so on and so on. Then at the end of the conversation, you get no feedback in that process, similar to what you would do with this very old school dictation solution.
Yeah.
At the end of the process, you're waiting for your note to be written, and in a lot of these solutions, the notes are quite cumbersome and long.
Yeah.
The first time you as a clinician, slow adopter, sees this long note and you see a small mistake, then you get really agitated, right? Because then you feel, oh no, now I have to read through this automatically generated language every time.
Yeah.
That's a real problem, right? Where it feels like we're so advanced now, where we are forgetting that the old school solution might actually, in a lot of instances, be the faster solution, right? 20-second solution. So, and this is a shameless plug here, but we just introduced what we call FACS-R, which is this recursive clinical facts extraction, we call it clinical findings extraction, that is allowing that live mechanism to happen, such that now the clinician can basically glance down, or they cannot glance down, but then so forth. And what the feedback that we get from the users is really interesting. Some of them really want to opt out of all of the facts from the get-go, and then they want to select the ones that they want in the documentation. Others, they want to deselect the ones that they don't want, right? But thereby they're back in the driver's seat of exactly what goes into their documentation, and they don't feel like it's that out of hands and out of grasp.
Control. Yeah.
Exactly.
Yeah.
So that gets very much closer to the loop of this old school feeling of the dictation solution that also had its problems, right? Because you didn't get the structure of the document. You needed to still actually get it into the SOAP and whatnot. And maybe it's not always 20 seconds, let's be honest, because it's also more cumbersome, and then you made a mistake, and then you needed to go back and all of that, and it was a little bit tedious of an interface. So I think that we need to, back to as technologists, we really need to ask ourselves, like, we need to make this technology really live, and we need to support that live workflow with the clinicians to really make them a part of that process. And that's what we believe in from the get-go. That's also why we made it so darn difficult to make our technology from the very beginning, because we said to ourselves, we always need to be able to process in real time, because if we're not, then we're not able to actually be that companion to the clinician, because that clinician is sitting in real time, right?
Yeah, exactly. And it comes back to, again, like that word that keeps coming up. It's that companion. It's a usable tool. You want it. Your research and your work has been around how, like, from the beginning of this being a tiny little ripple to the tsunami that generative AI within healthcare is becoming. You know, your research and your work is about how can we make this so that it becomes that indispensable tool for a clinician, that it integrates with those systems. So yeah, it's really fascinating. I'm so grateful for you taking the time and going slowly and making it so that I can understand it. Because I think it's like you said, I think these tools are really important, and our healthcare systems around the world are under increasing amounts of pressure. Our population is getting sicker and sicker and sicker, and clinicians for a long time have not been able to keep up with the load. So it's important that we develop tools that are trustworthy, will be inclusive models, and it sounds like you're working hard at trying to make that happen. So yeah,
always.
Very cool.
Thank you so much for the invitation, and let me know if there are any follow-up questions and so forth. Happy to be involved.
Yeah, we'll do. What I tend to advise my listeners to do is this will be going out on major podcasting platforms for people to listen to audio, because they like to listen while they drive, and it's a bit dangerous to watch and drive. But I also put it on YouTube, because that tends to be the easiest and best single platform for people to leave questions. So if anybody who's listening to this, whether you're a clinician or whether you're an engineer like Lars, if you have questions, drop them down below. I'll make sure that he gets a hold of them and can answer them and give us more information. And yeah, I will keep you posted. But it's been wonderful getting to meet you, and really enlightening to hear more about, from your perspective anyway, how you're trying to make AI an integrated part of our healthcare services rather than this thing that's getting pushed on us. So yeah, really very interesting. Thank you very much.
Thank you.
Don't go away. Up next, we have the top 3 takeaways from this week's podcast by Dr. Rosalind Austin. When Lars agreed to be a guest on this podcast, I was really excited because I'd actually had my first experience with a generative AI scribe in my own healthcare interactions, having been to my GP office and being seen by a nurse practitioner, and she had asked me whether or not I minded if our conversation was recorded as part of an AI scheme. I was really excited to get to speak to an engineer who had developed an AI version of what I'd experienced in my own healthcare interactions, as well as from my own interest around digital health, to try and get a bit more understanding in this field, more understanding in how these tools are being developed, how they're being tested, because it's a new area that I was really interested in trying to understand better and communicate to clinicians who I know are listening to this. For me, cards on the table, I got him to explain quite a bit of what he was talking about, because a lot of the terms are new or different, and the context of research within computing science is very different than the experience I have within health. So we do dive into some of that as well within this. So it's a really good, I hope anyway, that it serves as a really good introduction to clinicians who might be interested in AI, who are starting to learn some of these technologies, these terms, as well as the context of research within computing science and within AI. Now, for my top 3 takeaways. My first one, I loved how Lars, being an engineer and being a computing science engineer, goes back to a quote from Feynman, anything that I cannot create, I can't understand. And I think that's such a really powerful thought. And I think it applies to more than just engineers and software creation and, that computing science sort of things. And my PhD supervisor said similar but slightly different. If you can't describe what's happening, if you can't explain what's happening, then do you actually fully understand it? And I think what I really enjoyed about this conversation with Lars is that while, that was a driving force for him in getting into research, he wanted to understand stuff. And so in order to understand it, he started to create things that would reproduce that thing that he was trying to understand. And I think within health research, we do similar, but it can look a little bit different because we're trying to better understand the patient experience. We're trying to understand how we can improve that experience. And in order to do that, we have to characterize, we have to explain, we have to build that understanding in order to in a recreation through our research, in order to be able to then implement change or to improve those pathways, those interventions. So yeah, I really liked that way of thinking of it, of you have to be able to build it, you have to be able to describe it, you have to be able to recreate it in order to fully understand it. Second top takeaway for me is, and again, preaching to the choir here because you all know now that I quite love research, but he said, for him, the reason why he does research and why he has embedded research quite deeply throughout the development of his platform, the Corti platform, is that he believes that the only way to get better at something is research, and it's a hard thing to do, research, because you are getting better, you are improving knowledge, but it does mean that there's challenges. And we spoke about those challenges as in order to get better, in order to develop a better generative AI scribe. You have to be able to evaluate it. And as we develop new things and we develop new tools, we don't sometimes have all of the ways, the mechanics, the benchmarks to know how to evaluate something. So yeah, it gave me real food for thought, because yes, research is a way to get better at something, but research can only empower us to get better at something if we know how to evaluate that research that we're doing. Right, last one. And it leads on from my second one, is it's talking about that evaluation, and that evaluation is tricky, and being able to either quantitatively with numbers or qualitatively be able to evaluate the accuracy, the reliability, the validity, the usability, all of those itties that we read about in our research papers is really tricky, because they all depend on a full understanding of the goal of that. So, we talked about in this episode accuracy. So how accurate is something at doing the job that you asked it to do? Well, what do you mean by accurate? Do you mean a detailed description that's correct? Or do you mean something, accuracy of being able to condense that information into a readable short summary that packs in the details but extracts the usable information to inform that clinical decision making that benefits the patient, without requiring that clinician to read a 30-page essay. So learning how to evaluate things is really important. And one of the things that I really liked about this discussion is, within the computing science, which I'm still wrapping my head around, the use of synthetic data sets and the use of simulation in order to test these systems and be able to refine them alongside of that real world implementation. And I think understanding the power of some of those computing science tools could really help to open up some of those evaluation quandaries that we have. But I think there's also a real need, which he and I talked about a bit during this episode, of having that integrated collaboration of researchers between the computing science world, the clinicians who are using the tool, clinical researchers who understand about evaluation and clinical pathways, as well as that patient user experience. And so these things become so complicated because there's so many facets to them. So unlocking and understanding how powerful they are become complicated, and it becomes hard then as a clinician to know the tools that you're using, how trustworthy they are, how much of a companion they are, how reliable they are, all of those things. So it's definitely an evolving field, and something that we all need to be at, not just clinicians, but clinicians in computing science world need to be asking these questions together about how can we evaluate these tools so that we eliminate a lot of the waste around the development of health technologies that don't get used, that don't get implemented, but also that help us refine those tools so that they become, and I loved how he said this, they become that as easy to use as some of the Apple technologies or applications, or Facebook or Instagram, or all of those sorts of things. Like, those function so well for the user. And if he believes, and these are his words, not mine, if his tool isn't as easy to use, then he's done something wrong. But in order to make that happen, I think we have to have that multifaceted evaluation so that we know how to make sure that those tools aren't just not technically glitchy, but that they have clinical value and that they have patient value, so that there's buy-in from all of the different angles. Right. I think I need to go have a lay down now, because that was quite a whirlwind of information, and some of it new, some of it I've been reading about, but really hope that this has something that you enjoy. I know within healthcare services, there's a big push now, and I think the European Society of Cardiology are going to have a first digital and AI summit this year. So let me know, did you enjoy this? Should I dive into trying to speak to people like Lars to help us as healthcare researchers better understand these digital solutions that we are now starting to use and integrate into our practice? Let me know. As always, remember, like I said in the episode, like, comment, and subscribe. But more importantly, if you have specific questions for Lars, all of his details are linked into the episode description, and the comment section in YouTube is the best way to make sure that I can get those questions to him and you can get your answers. Thanks again for listening, and keep asking why.